In this video, we're going to look at the idea of proportionality, which is a very helpful tool when solving real-world problems. A lot of things are proportional to one another. So, first of all, let's just look at this phrase here. Y is proportional to X. We hear that sort of thing a lot. What exactly does that mean? Okay, so here's something that I learned when I first learned this concept that was helpful to me. When it tells me that Y is proportional to X, you could say Y, and then this is proportional to X. So this is kind of a alpha, the Greek letter. I don't know why, but the book that I learned this from used this symbol, and this is a way of writing that Y is proportional to X. Kind of like maybe Y is equal to X, or Y is less than X. It's a relationship between these two things. And what it means is that Y is not quite equal to X, but it's almost equal to X. What it is here, it's proportional to X. It's not equal to X, but it is equal to a constant times X. And so what you get here is you get an equation. Okay? If Y is proportional to X, Y is equal to a constant times X. And then you can use this, you can plug in values and use it to solve real-world problems. Now there's more than just, this is called direct proportionality. There's other types of proportionality. So let's look at some of these other types. You could have Y is inversely proportional to X. Instead, this is why, if it doesn't say directly proportional, just assume that it's directly proportional. Okay? But you could have Y is inversely proportional to X. Okay, and what this means is that Y is proportional to the inverse of X, or 1 over X. Okay, so Y is not equal to X here, or Y is not proportional to X, Y is proportional to 1 over X. And then using this same idea, what it means is Y is not exactly equal to 1 over X, Y is equal to some constant times 1 over X. Okay? The idea of proportionality is they're almost equal, you just need to have a constant there. And usually what we write here is we put the constant over X. So this is normally what we write. If Y is proportional to X, we would write Y is equal to some constant divided by X. That's what it means. But you can have other examples too. Oops, let me erase this. You could have some other examples. You could have Y is proportional to the square of X. Y is proportional to the square of X. What that means is Y is proportional to the square of X. Okay, it's not quite equal to the square of X, it's proportional, which means Y is equal to some constant times the square of X. And then you can use this equation to solve problems. You might have something that says Y is inversely proportional to the square of X. Right? So what is this? Y is inversely proportional to the square of X. So Y is, oops, sorry. Let me write this again. Y is inversely proportional to the square of X. So the inversely just means it's 1 over whatever this is. So this is directly proportional to the square of X. This is inversely proportional to the square of x. And what we would write here is y is equal to k over x squared. It's inversely proportional to the square of x. And this is actually a huge thing in a lot of physics and other science classes because of the inverse square law, meaning as something like gravity or light spreads out, the intensity of the light doesn't diminish inversely. You know, the further away you are, the less intense it is, but it's not inversely proportional to just the distance you are from it, but the square of the distance that you are from it. I can actually, let me see if I'll actually try to draw a picture of this. So if you're like 1 unit away, you would get 1 square, but if you're 2 units away, then you would get 4 squares, and then 3 units away you'd get 9 squares. And so the intensity of the light, it's all focused there, but 2 units away it's spread out. 3 units away it's spread out even more, and it's inversely proportional, but it's inversely proportional to the square of x. And you see this a lot in like gravity, the formula for gravitation, and other things in science. So that's a really important one. And you could have other ones too. I'm not going to write them all out, but maybe you're told that y is proportional to the square root of x. And that would just be y is equal to k times the square root of x. Or you might have that y is inversely proportional to the square root of x. So it would be y is inversely proportional to the square root of x, which would be y is equal to some constant divided by the square root of x. So you could have it be proportional to any function of x, and it just means y isn't equal to that function of x, but it's equal to a constant times that function of x. Or if it's inversely proportional, it's a constant divided by that function of x. And so this is a huge, very important concept that you can use. So let me just show you a little bit about how to use it. I got 3 problems here. So the first 2 are just generic problems. The first one says y is directly proportional to x. When x is equal to 7, then y is equal to 22.75. So what is y going to be when x is equal to 11? So here's the idea. This is saying y is directly proportional to x, right? Which is just saying y is equal to some constant times x. And so what it then does is it gives you an ordered pair that satisfies this equation. And that ordered pair here is 7, 22.75. Okay? And so now what I can do is I can plug these in to find my k. Okay? So when x is 7, y is equal to 22.75. So when x is 7, when I plug in 7, this is what I get for my y. So then my k is just equal to 22.75 divided by 7. And so I can do this, and I get 3.25. So what I find out here is that my k is equal to 3.25. And so now I actually have my equation. My function. Y is equal to 3.25 times x. And so now I can figure out what y is for any value of x. So now I just plug that in. 3.25 times 11. So 3.25 times 11, and I get 35.75. Okay? So that's the idea. So basically, you're setting up something with a k. They're giving you enough information to put in, and the information they're giving you is a ordered pair that satisfies that function, or that's contained in this function, and you plug that ordered pair in order to find this k is called the constant of proportionality. So once you find the constant of proportionality, you can place it in and actually get, here, the function, and then use that to solve whatever problem it is that you're trying to solve. And so it's really useful. So let's try another one here. It says y is inversely proportional to x, which is just to say y is inversely proportional to 1 over x is what it means. Or to say y is inversely proportional to x is just saying that y is proportional to 1 over x. And so that's just to say y is equal to k over x. And now what I can do is I can plug in my x and y here. So I get 3.4 for my y when x is equal to 5. Okay, so then my k is just, in this case, going to be 3.4 times 5. So 3.4 times 5. This gives me 17. So that means my function is just 17 over x. And now I can answer the question. It wants to know what is y when x is equal to 13. And so all I need to do here is plug in 13 and I can figure out what my y is. So 17 divided by 13. And notice this is kind of a messy number here, so maybe I'll round it to 2 decimal places. And so what I get is 1.31. Again, one thing is you want to get in the habit, if you're having to round, if your answer is like a repeating decimal like this is, and it's messy, and you're going to round, use this. It says approximately equal to 1.31. Okay, so that way they know that you round, and so this is what the answer is to 2 decimal places. Okay, and if the person needs to know it to more, then they'll have to go back and calculate it and round it to however many decimal places they need. But this indicates that that's not the exact answer. Okay, so that's the idea, and they all have the same flavor. You get to set up something with a k. You're setting up the function with a k, and then they're giving you one ordered pair, and that ordered pair allows you to find the constant of proportionality. You find k, and then you actually get your completed function, and then you can answer whatever question they give you, okay, that involves that function. So here's an actual real-world problem, okay, to see how this works. It says, when a rock is thrown off of a cliff, the distance it falls is proportional to the square of the time it has been falling. So if a rock falls 144 feet after 3 seconds, then how far does it fall in 5 seconds? Okay, so here's the idea. Let's let y equal the distance the rock falls. And then let's let t equal the time that it falls. And so what this is telling me here is that when a rock is thrown off the cliff, the distance that it falls, y, is proportional to the square of the time it has been falling. So that is just to say y is proportional to t squared. Okay, which is to say y is just equal to some constant times t squared. And now what it tells me here, if a rock falls 144 feet after 3 seconds, it's actually telling me, Zachariah, you're interrupting the video. Thank you. Okay, it looks like I just got something in the mail. Thank you, Zachariah. Let's see. I got to get my train of thought here. Okay. So the idea here is this information is giving me an ordered pair, and it's really important to make sure you get the x and the y, you get the coordinates right. In this case, the t and the y. So the 3 seconds, that's your t, right? And then the y here is 144 feet, right? So the ordered pair would be like 3, 144. Instead of x and y, it's t and y. Okay, so basically I'd put 144 is equal to k times 3 squared. And so I get 144 is equal to k times 9. So k is just equal to 144 divided by 9. Let's see what we get. And that actually comes out very nicely. It comes out to be 16. Okay? And so my final equation is going to be 16 times t squared. So the distance that a rock falls is equal to 16 times t squared. Okay? So now it wants to know how far does it fall in 5 seconds. So now I can just plug in 5 seconds, right? Like that. And so I really get 5 squared is 25, so 16 times 25 is 400 feet. Okay? So if it falls 144 feet after 3 seconds, it actually falls 400 feet after 5 seconds. So that rock is speeding up as it falls, isn't it? It's accelerating. This is actually a real world problem, and this 16, this is actually related to gravity. It's actually half of the acceleration due to gravity. So gravity is 32 feet per second squared. That's the acceleration. And this is half of 32. And that's actually a calculus thing. The reason that that's half of the acceleration due to gravity actually comes from calculus. We'll probably be seeing that later on. So this is a really nice example. But that's the idea of proportionality. They all have the same thing. You set up the equation with a k. They give you enough information that gives you an ordered pair. You plug it in to find the k, the constant of proportionality. And then you have your completed equation. Excuse me. And that can be used to go on and solve whatever problem you need to solve. So that's the idea of proportionality. You will see it probably a lot in some of the story problems throughout the class. It'll tell you that one thing is proportional or inversely proportional to some function of t or whatever, and then you're going to use that to set up the problem.